Hi there. Now in this tutorial what I want to do is show you how we can take an improper fraction and express it in partial fractions. So I'm assuming that you're familiar with improper fractions. If not, do check out the previous video. But just as a brief reminder, we look at the degree of the numerator, which is the highest power of x, which in this example is 2, and we look at the degree of the denominator, which is also 2, and providing the degree of the numerator is greater than or equal to the degree of the denominator, it's improper. So with this example, we've got an example of equal degrees, and I'm going to be doing in the next video another example where the degree of the numerator is greater than the degree of the denominator. So how do we go about splitting this into partial fractions? Well, the first thing we should do, I think, is just look at a numerical example where we carry out the division of an improper fraction. So we'll just put here numerical example. This will give us an idea of how we handle the algebraic equivalent. So suppose I took the top-heavy fraction 16 over 5, 16 fifths. What is 16 fifths? Well, 5 goes into 16 3 whole times, so that leaves us with 1 left over. And we say that's 1/5. So 16 fifths is the same as 3 1/5. Now if I was to do a division, say something like this, where I divide the 5 into the 16, I could set it out, say something like this. 5 into 16 goes 3 times. We know that because 3 5s are 15. And by subtracting the 15 from the 16, I get the remainder, 1. So the reason for doing this is because 16 divided by 5 then, as we've seen, is 3 1/5. But I can think of this as 3 whole ones plus 1/5. And when I look at the division here, I should be able to see certain elements where they appear in the division. This 5, for instance, clearly is our divisor. And then we have this 3 here, okay, which is called the quotient. And then we get the remainder, 1, okay, which appears here. And this is over the divisor, 5. So what I'm saying is that the first step when we've got to divide, say, x squared plus 3x minus 5 by x squared minus 1 is to do algebraic long division. And so if we look at the algebraic equivalent then, okay, let's just put that in, algebraic equivalent of what we've just done above, then we'll be dividing x squared minus 1 into x squared plus 3x minus 5. So just write that, x squared plus 3x minus 5. Now I'm assuming that you're familiar with algebraic long division. Again, if not, do check out the video on this. But briefly then, what we've got to do is say, what do we multiply that x squared with to get the x squared here? And it's going to be 1. And doing 1 times x squared minus 1 gives us x squared minus 1. And we put the minus 1 there. I could put underneath the 3x, no x, 0x. And then I work out the remainder by subtracting these two from one another. And x squared minus x squared is 0. 3x minus 0x, well, that's just going to be 3x. And then we've got minus 5 minus minus 1, well, that's going to be minus 4. So following the pattern that we've got here, I can see that where we had the 3, that was our answer up here, the 1. So what we've got is that this is identical to 1, and then we would add to this the remainder divided by the divisor. Well, the remainder is 3x minus 4, so I'm going to add to this 3x minus 4, and that is all divided then by the divisor, which for this example is x squared minus 1. Okay? So that splits it now into two fractions. Next stage is just to work on this as partial fractions. And again, I'm assuming that you have seen the previous videos in this series where we take something like this and split it into partial fractions. So again, if you're unsure of this, do go back and look at those earlier videos. However, we'll just carry on. Okay, so if we got something like this, what I would do is split x squared minus 1 up. I can factorize it. So what we've therefore got is x squared plus 3x minus 5, all divided by, well, this is the difference of two squares, so it factorizes to x minus 1 times x plus 1. And this is going to be then identical to the 1, and then this is going to be plus 3x minus 4, and again I'll factorize the denominator here as x minus 1 times x plus 1. So splitting this into partial fractions now, because it contains two linear factors, I can say that this is going to be identical to the one that we've got here, plus, and then it'll be a constant over the first linear factor. I'll call the constant a, as we've done in the past, and then plus another constant, let's say b, over the other linear factor, x plus 1. Now to work out a and b, what we've done in the past is multiply both sides by the denominator here. So I'm going to multiply both sides by x minus 1, x plus 1. And if I do that, we therefore have on the left here just x squared plus 3x minus 5. And then this is going to be identical to 1 times x minus 1 times x plus 1. So I'll write that in like so. I could obviously write just x squared minus 1. It's the same thing. It's up to you. When we multiply this term with x minus 1, x plus 1, we're just going to be left with a times x plus 1. And then when we take the last term here, it'll be plus b times x minus 1. And in the usual way, we choose values of x which take out one or more of the terms. And I can see that by choosing, say, x equaling 1, we'll make this bracket 0 and take out this term. It will also take out this term as well when x is 1, because this bracket will be 0. So let's do that when x equals 1. When x equals 1 then, what we've got is that 1 here plus 3, which is 4, minus 5 is going to give us minus 1. This term is going to go to 0. This is going to be 2a. This will be 0. So we just get minus 1 equals 2a. So therefore a must be equal to minus a half. And then we'll go on, see if we can work out what b is. And we can do that by making this bracket 0 by choosing x to be minus 1. So when x equals minus 1, we therefore have minus 1 squared is 1, minus 3, so that's going to be minus 2, minus another 5 is minus 7. Minus 7 then equals, this term will go to 0, this term will go to 0, and here we'll have minus 2b. And so therefore, dividing both sides by minus 2, b turns out to be 7 over 2. Okay? So all we need to do now is just substitute our values of a and b back into our identity. So if we start with x squared plus 3x minus 5, then all divided by x squared minus 1. We can see that this is identical to the 1. Okay. Then it says plus a over x minus 1. A is a negative value, so we just can replace that with minus, and it'll be 1 divided by 2 times x minus 1. And then we've got plus b. B is a positive value, so it's going to be plus 7 over 2 times x plus 1. And there you have it, your partial fractions. So I hope that's given you an idea how to do that by considering the numerical example. So this was for equal degrees. You might like to try the example that follows in the next video, where I make the degree of the top greater than the degree of the denominator. Same process though, okay? So do give that a try.